ठीक आहे शिखा मॅडम आणि ह्या मॅडमला नंबर पाठवते मी. एक नंबर पाठवते. मॅडम मी जॉईन केली तुमच्या त्या मॅडम आहे ना, त्यांच्यासोबत तुला कॉन्टॅक्ट करायचा आहे काही राहिला तर. मॅडम मी दोन पुण्याचा नंबर पाठवते. काही राहिलं वगैरे नाही झालं जॉईन जैसे दोन लोक असेल तो नाही आणि दोघींचं हे काय एकदम कमी आवाज रात्री त्यांचा हेडफोन लावा. हो हो.
Rajni ma'am, is my voice is audible?
येस मॅडम ऑडिबल. हो फक्त त्याच्यातून आवाज राहील ना किंवा तुझा प्रॉब्लेम राहील ते. हां मी काय म्हटलं मी तू एक काम कर ना SGMMवर आहे ना एक मेसेज टाक जॉईन करा बनवून. हो लिंक टाक. तिथेच असेल ना थोडा वेळ. कल्पना करवा आपल्याला कधीला समजू.
Hello, Dr. Rajni madam, let me start.
Yes madam. Now we will start.
Okay. Okay. Hello friends. Good morning and thank you for all finding the time virtually visiting the today's webinar. First of all, it's my duty to pay the respectful tribute to great revolutionary man of humanity and unity Rashtrasanta Gadge Maharaj and our source of inspiration late Shri Dr. Sudhakar Rao Moglewar, the founder, president and man of vision who spread the education to the rural India. So, in this auspicious occasion, I extend my warm welcome to all the respected dignitaries of the function and my dear participant for your gracious presence in this virtual platform. I am Dr. Rupali Chaudhary, the Department of Botany, Sant Gadge Maharaj Mahavidyalaya, Hingana. Feel privileged to welcome you all on behalf of organizing committee of National Webinar on Development of in Cosmology and Modified Gravity 2022. For that, we are assembled here. So this national webinar is jointly organized by Department of Mathematics and Department of Physics of Sant Gadge Maharaj Mahavidyalaya, Hingana. So, Before we go ahead, I want to give some instruction, and it's my humble request to all the participants. Please follow the instruction come request for the smooth conduction of the event. To keep the quality of sound functional during the meeting, please mute yourself when you are not sharing. Participant, please keep your mic and video off so that we can conduct the program smoothly without any technical interruptions or error. So now I request Honorable Principal Dr. Aarti Moglevar Madam for her inaugural address before this August gathering. So please, Dr. Aarti Moglevar Madam.
Good morning, one and all. I am Dr. Aarti Muglevar, Principal Sant Gadge Maharaj Mahavidyalaya, Hingana. It is a great pleasure to welcome all the participants, research scholars and students to all the national webinar on development in cosmology and modified gravity 2022, which is the jointly organized by Department of Mathematics and Department of Physics, Sant Gadge Maharaj Mahavidyalaya, Hingana. I congratulations to Rajani Anturkar and Dr. Ritesh Kole for successfully uh, organization the program. Our faculty members are committed to stay focus on academic excellence and pursuing highest academic standards while also serving our local and global communities. So today, invited speaker of this webinar definitely contribute and fulfill subject knowledge. Participate and dear student will definitely help to upgrade our knowledge regarding the development of cosmology and its future prospects. Modern scientific cosmology and valuable in itself for what it reveals about the nature of the cosmos we inhabit. It is a demonstration of the power of modern science and transfer of our understanding of who are and where we come from. Without taking too much of your valuable time, I announce this webinar inaugurated. Thank you.
Okay. Okay. Thank you so much, madam. Thank you so much, madam, for your valuable guidance and introductory remark. You always motivate us to organize such kind of activity, and you always support you in this regard. Thank you once again, madam. Now we are move ahead. I request respected Dr. Ganesh Maivade sir, the Vice Principal and IQAC Coordinator of our college, for his valuable remarks. Please, Dr. Ganesh
Thank you,
Maivade
madam.
sir.
Good morning, all. I am Dr. Ganesh Maivade, Vice Principal and IQC Coordinator of Sant Gadge Maharaj Mahavidyalaya, Hingana. As a coordinator of this program, I welcome Honorable Sri Uday Muglevar, Secretary, Basaveshwar Education Society, Nagpur. I welcome Chairperson of this event, Dr. Aarti Muglevar, Principal of Sant Gadge Maharaj Mahavidyalaya, Hingana. I extend my warm welcome to resource person Dr. Shikha Srivastav, Associate Professor, Department of Mathematics, Faculty of Science, Aligarh Muslim University, Aligarh, UP. I welcome resource person Dr. Kalpana Pawar, Head and Associate Professor, Department of Mathematics, Sri R.R. Lahoti Science College, Morshi. I heartily welcome distinguished participant, research scholar and student from various states. I behalf of Sant Gadge Maharaj Mahavidyalaya, Hingana, to the national webinar on development in cosmology and modified gravity 2022, which is jointly organized by Department of Mathematics and Department of Physics. I congratulate Dr. Rajni Anturkar and Dr. Ritesh Kole, convener of this program, and also organizing committee members for their continuously taking effort for organizing this program. Definitely, such program help researcher and student to enrich their knowledge and encourage them to research in the advanced science concept. I really appreciate of effort our faculty are putting in to grow the persona of student and hence contributing to the growth of the nation. I wish good luck for outstanding success of this event. Thank you and have a good time ahead. Thank you, madam.
Thank you, sir. Uh, your valuable inputs always show the path and help us in micro planning to execute the activity. Thank you once again, sir.
Thank you, madam.
Okay. The organization of this important event is the brainchild of Dr. Anturkar madam. And today, really, it is come true with a great success by overwhelming response of the participants across the India. So now it's time to call Dr. Rajni Anturkar madam, the head Department of Mathematics and conveners of the today's webinar. So it's time to call Dr. Rajni madam. Over to you, Dr. Anturkar madam, please.
Thank you, madam. Good morning, one and all. I am Dr. Rajni Anturkar as a convener of the webinar. On behalf of Sant Garge Maharaj Mahavidyalaya, I am delighted to welcome you all to this webinar on topic developments in cosmology and modified gravity organized by Department of Mathematics and Department of Physics. In this webinar, we have tried to involve a thoroughly complete survey of recent work on modified theories of gravity and their cosmological consequences. The purpose of this national webinar is to provide a reference tool for researchers and students in cosmology and modified gravity, as well as self-contained, complete, and up-to-date introduction to the subject as a whole. These subjects have been intensively studied over the past decade, largely motivated by rapid progress in the field of observational cosmology that now allow for the initial time precision test of fundamental physics on the scale of the observable universe. In this webinar, we have around 200 participation for various states from Tamil Nadu, Uttar Pradesh, Jammu Kashmir, Madhya Pradesh, Goa, Uttarakhand, Assam and Maharashtra. We are highly encouraged to have such a great participation and interest. Thanks all of you for showing interest. I am deeply obliged to the principal of our STEM Institute, Dr. Aarti Moklewar Madam, Vice Principal, Dr. Ganesh Mavade Sir, all faculties and my colleagues, who demonstrated remarkable integrity and commitment during the present preparation of this webinar. I truly believe the involvement of researchers and students from different colleges, states attending today will certainly make the webinar fruitful and productive. It is true that every effort is not converted into success, and success does not come without effort. Therefore, I hope this effort will provide opportunities to all delegates to interact with speaker and get familiar with recent developments in cosmology and modified gravity. We completely appreciate you finding time despite your busy schedule and being a part of this event. Once again, I extend my heartiest welcome to all our esteemed guests, speakers, and delegates. We are sure that this event will be a memorable and not to be missed event. Thanking you. Have a wonderful day.
Okay, thank you so much, madam, for your brief overview around the theme and participation and resource person of this seminar. Thank you once again. Just a little housekeeping before we get started. If you have any questions, because now we are starting the presentation, so before that I want to give some instruction or request. If you have any questions during the presentation, please type them into the chat box. I will bring them up during the presentation if necessary, or we will also have the time for the question at the end. And again, the request to please keep off your mic and the video so that we can hear the program smoothly without any technical problems or without any interruptions. Now we are moving ahead to the next technical session. For that, I request Dr. Madhuri Bhonde Madam, Department of Botany, to please introduce our eminent resource person for the first plenary talk. Over to you, Dr. Madhuri Bhonde Madam.
खूप निघाले खूप झाली काय
Thank you, Dr. Rupali Chaudhary, ma'am.
खूप झाली
Good morning, one and all. Myself, Dr. Madhuri Bhonde, Department of Botany, Sant Gadge Maharaj Mahavidyalay, Hingana, District Nagpur. A warm welcome in today's national webinar on developments in cosmology and mathematical gravity, organized by Department of Mathematics and Department of Physics.
ऑफ का बरं मला
Our inspiration and founder, late Dr. Sudhakar Rao Moglewar, Honorable Principal, respected Dr. Aarti, Aarti Moglewar ma'am, Vice Principal Dr. Ganesh Maiwade sir. I am very much glad to introduce you today's first eminent resource person, respected Dr. Shikha Srivastava ma'am. Dr. Shikha Srivastava ma'am is an associate professor in Department of Mathematics in Aligarh Muslim University, Aligarh. Dr. Shikha Srivastava ma'am completed her PhD from VBS.
SGMM वर पाठवलेला आहे मुलांना सबस्क्राईब पण करायला लावशील मॅडमचा आवाज गेला भोंड मॅडमचा आवाज गेला भोंड मॅडमचा आवाज गेला
Sorry for the interruption. She has completed her PhD from VBS Purvanchal University, Jainpur in 2012. She has completed her BSc and MSc from VBS Purvanchal University, Jainpur, with first division in 1999 and 2012 respectively. She was invited as a speaker in international conference on differential geometry and relativity in 2019, organized by Department of Mathematics and Statistics, DDU, Gorakhpur University, Gorakhpur. Dr. Shikha ma'am organized national and international conferences. She has published near about 19 to 20 research papers in reputed national and international journals. Madam has communicated 3 research papers. They will be published in the future. Madam has presented papers in national and international conferences. Dr. Shikha Madam has area of interest is general relativity, dark energy, modified gravity theory, and cosmology and astrophysics. Madam is the member of Central Accuracy Committee, GLA University, Mathura. She also member of Central Examination Flying Squad, GLA University, Mathura, UP. She is a member of Admission Committee, GLA University, Mathura. She is member of DQAC Committee, Department of Mathematics. She is member of Conference Organizing Committee, Department of Mathematics, GLA, University, Mathura. She is member of Student Counseling Committee, Department of Mathematics, GLA, Mathura, Uttar Pradesh. Now I have request to Dr. Shikha Srivastava ma'am to deliver her lecture. Please, Dr. Shikha Srivastava ma'am.
Thank you, Madhuri ma'am, for inviting me, and thank you, Dr. Rajni, for inviting me in this workshop. And I'm audible to you all. Is I audible? Am I audible?
Yes, ma'am.
Yes, madam, you are audible.
Yes, yes.
And thanks to Vijaya Mahavidyalaya and for inviting me this for this workshop. And today I'm giving the lecture on the basic lecture of cosmology and general relativity. We are all live in a universe, and we have so many questions about universe. What is universe? कैसे बना? How? what is the formation, what is the geometry, and the main work that I'm working on this is the dark energy. As you know that, just a minute. Is my screen visible to you all?
Yes, madam.
Yes, ma'am.
Yes, ma'am.
My today's topic is general relativity and cosmology. I will some basic lecture, some basic idea about. Is there any problem with my voice? Hello.
हाँ हेलो मैडम एक्चुअली देयर इज इको साउंड साउंड इज है ना राइट
Okay. It's not from my side ना. देखिए उसको चेक करिए. ठीक
ओके
है.
ओके मैडम
Okay. So I'll come to my topic, general relativity and cosmology. The first thing is what is cosmology and why we are studying about the universe. The cosmology is the study of origin, evolution and structure, formation and ultimate fate of the universe. And there are two aspects of cosmology. As you see that there are some physicists working on the nature of universe, and we all are mathematician. And we are also working on cosmology. Then there are two aspects of cosmology: theoretical cosmology and observational cosmology. The mathematicians work on theoretical cosmology, and the physicists are working on observational cosmology. Both are based on mathematics and scientific reason. Another aspect of cosmology, creation myth, and these are non-scientific. So, as you know that I am a mathematician, so I let's understand the theoretical aspect of universe with some observational evidence. As you know that our universe is expanding, आपको पता है universe जो है वो expand कर रहा है, and there are some of universe. This is the 70% of universe formation is of dark energy, 25% is dark matter, and other is the baryonic something. The my lecture based on the Big Bang theory, the big picture of the expanding universe, and some mathematical cosmologic model, and then the conclusion and future scope. See, when the cosmology started, the universe is homogeneous and isotropic at large scale. It cannot be stationary, it should expanded or contracted. The observation tool said, universe is expanding, Hubble ने इस पर काम किया, and it should have a beginning. CMBR is the third observation, and this is hot Big Bang. The fourth observation is absence of light element, that is confirms hard Big Bang, fate of the universe. The fifth observation, density measurement and the background radiation. Lastly, recently we find that the universe is nearly flat and it contains dark matter and dark energy. What are the problems with the standard Big Bang model? That is the theory of information. Why? Our universe has the parameter that we observe. The universe must have those properties which allow carbon-based life to develop within some stage in history. This is the picture of universe, In this picture, you can say that you can see that universe is very inhomogeneous and anisotropic at smaller scale. But homogeneous and isotropic at large scale. The cosmological principle says that the universe is homogeneous. It means there is no preferred observing position in the universe, and the universe is also isotropic. These are the cosmological principle. Considering the largest scale in the universe, we can provide the fundamental assumptions based on three: homogeneity, isotropy, and universality. What is the homogeneity? On the largest scale, the local universe has the same physical property throughout the universe. As in this picture, you can say that every region has the same physical property: mass, density, expansion rate, dark matter, etc. Isotropy, on the largest scale, the local universe is the same in the direction, in any direction, and that one observed. Means you can see that you should see the same large scale structure in any direction. And the universality, it means the law of physics are the same everywhere in the universe. This is the Big Bang theory. This is a scientific theory about how the universe came to exist and all the stuff we see today. The Big Bang theory able to explain the observable universe for better than any other theory proposed till date. I am giving the thermal history of universe, uh, Planck, Koch, and general uniform, dark matter freeze out, and dark energy matter quality. These are the technical data you can read this. The Big Bang picture of expanding universe is that till the end of 20th century, we believed in an expanding universe and on the slowing down expansion due to gravitational pull. But the discovery of accelerating expansion in 98 and 99 changed the view of scientific think about the late time cosmic acceleration. The scientific theory behind this is static universe, expanding universe, collapsing universe, and accelerating expanding universe. This is the present scenario of the universe, that the universe is expanding with acceleration. The cause of expansion is dark energy. There are much more to be discovered in the universe to answer our question of very beginning phase and the dynamics. What is the behavior, what is the structure, and what is the rate of expansion. ये सारी study करने के लिए there are so many dark energy और अभी बहुत कुछ भी study करना है. As I told you that the mathematician study about the theoretical cosmology, and the question is that this is the mathematical cosmology. This is based on different aspects of mathematics. The past few years of research by physicists and mathematicians gave some spectacular mathematical model of the universe. There are some standard model, these are called Big Bang model and other. And some of the proposed theory beyond Big Bang theory are bouncing multiverse, steady state, string theory, and other. The standard model is based on cosmological principle. The universe is homogeneous and isotropic on large scale. That is, the universe appears to the same everywhere in all directions. The background theory for the standard model is general theory of relativity proposed by Einstein in 1915. And what is the general theory of relativity? Our universe has four dimensions, three space and one time, as you all know about that, which together form a quantum known as the space-time fabric. Gravity is not a force, but the curvature of space-time around an object. Since the space-time bends around the heavy object, time slows down as you move closer to the center of the heavy object. Since light follows the curvature of space-time, it bends around heavy objects like sun. Speed of light remains constant for observer in all frame of references. As a result, time slows down, a length contract in the direction of motion of I speed. The speed of light is the maximum speed that can attain in our universe. The background of mathematics of general relativity is totally based on Riemannian geometry. This is the equation, and G mu V is Einstein tensor, and T mu V is energy momentum tensor, describe distribution of matter in space-time. General relativity gives geometry, which is used by matter and energy. Space-time tells matter how to move, and matter tells space-time how to curve. This is the Einstein field equation, and G mu V is Einstein tensor, R mu V is Ricci tensor, G mu V is metric tensor, curvature scalar, and this you all know about, you all familiar about this equation. This is known as Einstein field equation. And this is the equation R mu nu, this is volume of space-time curvature, and this. Once we specify the geometry and the matter contained in the universe, mathematical model of the universe can be constructed. Then we can study the physics and geometrical properties of the universe with various mathematical tools. The obtained model can also be compared with the observation using statistical and computational tools. Again, I am discussing the cosmology and general relativity. What is this? According to the theory of general relativity, gravity is caused by the curvature of space-time. The effect of gravity on the largest cosmological scale should be related to the curvature of space-time. The curvature of space-time in turn is determined by the distribution of mass and energy in the universe. What space-time tells? Space-time tells matter how to move, and matter tells space-time how to curve. General relativistic model is matter, mass, pressure, all are in Einstein equation, and it gives geometry of space-time. As the Einstein thought of the space-time is three-dimensional and one time dimension, and represented as a Riemannian space metric, that is ds square is equal to this, where Riemannian metric is this, DS is independent of coordinate system and is termed as line element. GIJR arbitrary function of coordinate xi. RIJR calculated using this, आप सभी ने किया होगा and you know about that, where this is Christoffel symbol and you can calculate using this identity, and gravitational field equation are derived by Einstein-Hilbert action principle. This is there. The energy momentum tensor is also defined and can be calculated by this, and the equation written in this form, that is Tij is equal to,
यांची
here I am giving some general relativity picture. Due to presence of matter, the universe is not stationary. All distance changes. Scale factor is a function
आज
of
पण
time.
बघाल हो पण खूप छान लेक्चर
The metric of homogeneous and isotropic universe,
सगळ्यांचे
that
एकदम
is
सगळं
Roberts,
प्रोग्रेस
Walken and
झाले आणि
Friedman
बाकीचे लोक म्हणजे
FLRW
सुरूच आहे
equation
तुला
is
रिक्वेस्ट सुरूच आहे की करा
ds
म्हणून
square is equal to this.
काय म्हटलं
Compare with
हो
metric for empty flat space, you can find this, and the scale factor RT describe the expansion of contraction, that is curvature is equal to this. As you know about the Einstein equations, equation of state, P is proportional to rho c square, and these are the equations you can find the ht, the acceleration, and some other thing. The main equation is given by this, and there
आले ना सुद्धा आहे ना
you can find
खाली
the critical density, and
हॅलो
when
खाली
rho is less than rho c, you can k less than 0. When rho is greater than rho c, k greater than 0, and rho equal to rho c. Here, I'm again discussing some cosmological model, the FLRW model.
ठीक आहे मी करून घेते ते मी लिहिते आता बरोबर हो ठीक हो हो
The
ठीक
RW line element
हो करते मी
is
लिहिते पण बाय
Einstein field equation are derived by this. Where A is the scale factor, वहाँ पर हमने RT से कहा था, यहाँ पर मैं A से इसको define कर रही हूँ. Where A is the scale factor, K is the curvature parameter, and rho and P are the energy density and pressure of the energies in the universe. This is the metric of the solution of Einstein field equation is called a cosmological model. जब आप Einstein field equation, if you want a solution of Einstein field equation, this is called a cosmological model. With the general setup, stated above, by considering a Riemannian space-time and defining the matter contained in the universe, mathematical model can be constructed. Here I am giving the picture when k equal to -1, k equal to 0, and k equal to +1, the negative hyperbolic, the positive spherical, and so on. The Einstein field equation are non-linear second order differential equation. In order to find a deterministic solution, one need to specify the matter content precisely. The matter content in the universe is generally considered the perfect fluid for which density greater than 0 and P also greater than 0. The EOS, that is equation of state for perfect fluid, is P is equal to omega B, as it is varying from 0 to 1. From two Friedman equation, it is easy to derive rho dot plus 3h p plus rho equal to 0, which for perfect fluid, EOS gives the solution this. For k equal to 0, the solution gives scale factor proportional to this, where T naught is constant. W is equal to 1 by 3 correspond to radiation when AT proportional to this and rho is a to the power minus 4 and W equal to 0 correspond to matter, it is the dust. With these solution, the acceleration is always negative, that is a double dot less than 0, implying a decelerating expansion of the universe throughout the evaluation. But recent cosmological observations suggest accelerating expansion of the universe, which cannot be described by the usual matter content in the standard scenario. There are two simple ways to describe the observed cosmic acceleration. That is by dark energy model and by modified gravity model. What are the two ways? Adding extra source term with high negative pressure in the RHS of
Please off the mic, Pratik Ekulkar.
adding extra source term with highly negative pressure in the RHS of Einstein field equation, that is dark energy model, and the modifying the gravity in the LHS of Einstein field equation, that is modified gravity model. The past few years of researcher in cosmology produce a plethora of cosmological model in these two scenarios. बहुत से काम हुए डार्क एनर्जी मॉडल्स पर एंड मॉडिफाइड ग्रेविटी पर. देयर आर सो मेनी डार्क एनर्जी मॉडल्स, दैट इज बैरो holographic dark energy model, holographic dark energy model, Renine dark energy model, Ricky dark energy model, age graphic dark energy model, Tishalis dark energy model, new age graphic dark energy model, and so on. I'm also working on the dark energies. The past few of researchers in cosmology produce this. However, there are not only two possibilities, there are several other ways to describe the idea of cosmic acceleration. Moreover, there are arguments against the very idea of cosmic acceleration also. But here I am discussing only the dark energy model. We do not know more about dark energy, as its name is dark energy, so we have very less knowledge about dark energy, and the laboratory test is also not available for the dark energy, but we can consider it is a homogeneous fluid that moves all over the space. The several candidates of dark energy are cosmological constant, Chaplin gas, quintessence, and so on. The dynamical dark energy model with the scalar field models are much more popular to theoreticians. The Einstein field equation is generally characterized by the following basic parameters: some physical parameter and some geometrical parameter. In geometrical parameter, there is scale factor, Hubble parameter, and deceleration parameter. And the physical parameters are energy density, pressure, and EOS, that is equation of a state parameter, that is P by rho. And Hubble parameter, you know that A dot by A, and the deceleration parameter Q is A A double dot by A dot square. Some other parameter are Einstein cosmological constant lambda, which is arises in Einstein modified field equation, density parameter ohm, shear parameter, scalar expansion theta, and some other. When you are solving these type of parameter, you have knowledge about these shear factor, scalar expansion, and other. The redshift may be characterized by the relative difference between the observed and emitted wavelength of an object, and it is related to the scale factor by this. In FRW cosmology, Einstein field equation contains three variables: scale factor, pressure, and density. The two independent equations that can be solved by the equation of state, the system become more complicated with the addition of extra degree of freedom. Dark energy density, the EOS becomes dynamical with dark energy. The cosmic acceleration and lambda CDM model. The first evidence by observation of supernova and later on the CMB, LSS Planck and many more observation are there. मैंने यहाँ पे आपको कुछ pictures दिखाई है. In this picture, you can see that the lambda CDM model fits well to most of the observational data set, and it is preferred model. But the dynamical dark energy is more sophisticated and need to considered as well. The lambda CDM model is the best and appropriate model for the cosmic acceleration. As you know that we are living in accelerating universe, so this is the diagram of accelerating universe. Ohm is equal to 1, lambda greater than 0. This is accelerating phase, empty universe, and this. Einstein modified field equation with a cosmological constant lambda are this. When you are adding a cosmological constant lambda in Einstein field equation, you will find this. In this case, one can obtain that the deceleration parameter Q comes about to be -1 and interrupt as accelerating expansion. When Q comes out to -1, you can say that it is the universe is in accelerating phase. But lambda suffers from cosmological constant problem, so other possible alternatives are to be explored. Here I am giving some cosmological parameterization. In literature, there are different motivations to choose an extra constant equation that makes the system determinable. Here we adopt a very simple mathematical way to study these dark energy models, or the modified gravity models, generally referred as cosmological parametrization, which is model independent and do not affect the background theory. The above discussed cosmological parameter can be study the properties of dark energy and evolution of the universe. The cosmological parameterization also provide the simple techniques to construct the cosmic history and in studying the fate of the universe. For a brief summary of different scheme of parameterization used by theoretician, a fine solution of Einstein field equation in the last few year I'll give. You can see in the appendix I'll give in the last of the slide. The solution thus obtained can be derived and constrained through different techniques. the theoretical analysis and observational constraints. The dynamics of the universe, the evolution of the universe can be described through the physical and geometrical parameters that can be analyzed in details. The variation of cosmological parameter can be shown in plots with respect to time or the redshift. Here we are plotting the curve with respect to time and the redshift z also. You can see the nature of the universe by or the nature of the parameters by these graphs. The diagnostic state finder and ohm diagnostic are the tool of discuss, compare and distinguish different dark energy model to higher derivative of scale factor. By these diagnostic, I'll also work on the state finder diagnostic. You can compare the dark energy models by defining the state by working on the state finder diagnostic tool or code diagnostic. Dynamical system analysis. The dynamical system theory is in fact a geometrical approach. What it is? It aims to describe the evolution of the system under consideration in a given geometrical space rather than to determine analytic expression for the solution. And observational constraints, this is always working on the laboratories, that is model parameter can be constrained through these CMB, BO and some other data sets. I'm giving an example of dynamical dark energy model. Uh, you can work on so many dark energy model, but here I'm taking a Hubble parameter as beta t to the power m over t to the power m plus alpha to the q, where alpha beta not equal to 0, m and p are real constant, and alpha and beta both have the dimension of time. The specific value of m and p will suggest the different form of holographic principle parameter and produce interesting cosmologies. In this parameterization, several node models were obtained by any cosmological parameters, scale factor, Hubble parameter, dissipation parameter, cosmological parameter, equation of state, and density and pressure. This one parameterization cover any model obtained in the past few decades in different scheme of parameterization under one umbrella. This simple modification in the functional from the can give rise to interesting cosmological phenomena such as big rip singularity, bounce and others. Few models admit transition from deceleration to acceleration as suggested by some observation. We can see the following table. In these models, we are taking some specific values of Mn and P, and we are getting the Hubble parameter, the scale factor, and the deceleration parameter like that. And by taking these specific values of M and P, we are plotting the graph of Hubble parameter, deceleration parameter, and scale factor like that. And these graphs are the plots of deceleration parameter obtained by this, and you can see that how the phase is decelerating to accelerating or accelerating to decelerating. If we are taking the negative alpha and beta, the phase transition and the Hubble parameter can be expressed in term of redshift as hello.
Yes, madam.
Okay, okay. The Hubble parameter uh, can be expressed in terms of redshift, means in the last slide I'm giving the Hubble parameter in terms of t, and here it is in terms of z, and you're plotting this the value of alpha beta, and this figure shows that the alpha beta plane for the above two models. The best fit values of alpha and beta obtained by minimizing the chi-square with this error and obtain this. There are some appendix and the physicists and mathematicians gives about the knowledge, and now this is over to cosmology and general relativity, but I have some other informations about that's the nature of universe, and I want to share with you. Uh, See, as the universe cannot be stationary, as you know that it is in expanding phase, तो ये stationary नहीं है. Force per unit mass is this, energy per unit mass is this, and the Hubble proves that the universe expanded. It proves that it is the, and this is the Hubble's law, and in the Hubble's law you can see that the expansion of our universe, and what is the necessity of Big Bang theory? You can see that if galaxies are moving away from each other with a speed proportional to distance, there must have been a beginning when everything was concentrated in one single point. And what is the age of the universe? Knowing the current rate of expansion, this is the age of universe. This is Newtonian model of the universe, and I'll give some pictures on the expanding universe. As you know that the Rees and all are working on the universe is expanding in 98 and 99. So on large scale, galaxies are moving apart with velocity proportional to distance. It's not galaxies moving through space. Space is expanding, carrying the galaxies along there. These are the some pictures on uh, expanding universe. And now over to this. This is, if you people have any doubt, any please ask me.
Yes, madam. Participant, if you are any query or the questions in your mind, please write on the chat box, or you can ask to madam.
Madam, one question from Akshay Nekar. That is,
Yeah.
what are the application of cosmological models?
Uh, what are the
Application of cosmological models.
application of cosmological? If you want to know about your universe, the cosmology, there are several cosmological model, and they are very familiar about the universe of the nature of the universe. That is, अगर आप जानना चाहते हो कि यूनिवर्स में क्या चीज कैसे हो रही है, एक्सपेंडिंग है, कौन सा मॉडल फिट हो रहा है, देन यू कैन सोल्व दिस बाय कॉस्मोलॉजी.
Okay. Uh, Also, one question from Dr. Rajdeep Bhutane. That is, explain four dimension.
Explain four dimension.
Yes, madam.
You know that in general relativity there are three dimensional, and the one more is the time reference. This is the four dimensional space. जैसे time के about कोई चीज vary करे, just as Einstein said that कि if you are reading a very boring chapter and you say that you imagine that the time is very slow moving on. अगर आप कोई boring chapter पढ़ रहे हैं तो आपको लगेगा कि 2 घंटे बहुत ही कम है. But if you are watching, if you are seeing a very beautiful lady and for 2 hours and you say that, oh, time is going very fast, this is the relativity. And the relativity said that the dimension is the universe is have four dimension, x y z, you know that, and the fourth is the time of reference, that is t.
And one last
टाइम
question.
के रिगार्डिंग बात करेंगे. जैसे मैंने आपको बताया कि अगर आप इफ यू आर वाचिंग अ वेरी ब्यूटीफुल लेडी, दैट इज कैटरीना कैफ को अगर आप देख रहे हैं तो आपको लगेगा कि 2 घंटे बहुत जल्दी पास हो गए, और आप बहुत ही बोरिंग लेक्चर पढ़ रहे हैं तो आपको लगेगा कि अरे 2 घंटे पास ही नहीं हो रहा है. दैट इज रिलेटिविटी, आइंस्टाइन का कोट है ये, और आप उसको देखिए.
Uh, okay, madam. One more question from Dr. Dhankar sir. That is, what is the difference between general relativity and differential geometry?
Differential geometry and general relativity. Geometry said that the ज्योमेट्री ऑफ यूनिवर्स, जैसे आप बता रहे हो कि कर्वेचर जो हम आपकी बात कर रहे हैं, दीज आर दो टू डिफरेंट पोर्शन, दीज आर टू डिफरेंट विंग आप कह सकते हो. जनरल रिलेटिविटी अलग चीज है, डिफरेंशियल ज्योमेट्री अलग चीज है. डिफरेंशियल ज्योमेट्री जैसा नाम ही आ रहा है तो किसी चीज की ज्योमेट्री बता रहा है वो, ठीक है. रिलेटिविटी जब हम पढ़ रहे हैं तो हम आप उसके रिलेशन में उसके स्टडी हम कर रहे हैं उस चीज की. तो this is not I think this is not a very nice question about that.
Okay. All participants, just to inform you all, madam has delivered such a great lecture on the subject, despite not feeling completely well. Respecting this, I request you all to please share your question in chat window. I will share it with madam and also madam phone number. Thanks for your kind
Okay,
cooperation.
okay, you can.
Okay.
Rajni, but it's really regretting for me because I'm not feeling well. आपको जैसा मैंने बताया था, as on or demand मैंने lecture दिया. I, I was hospitalized last night, and there is very basic lecture. In future, I'll give you some other more advanced lecture on baroholographic dark energy. I'm also working on many dark energies, and I'll give some advanced lecture on that topic. So thank you, Rajni, for inviting me.
Good morning, ma'am. Thank you for giving a wonderful talk. Ma'am, I have a question. Can I ask?
Yeah, you can.
You use a term local universe.
Yeah. In slide number.
Uh, I think you're defining isotropy. There you use local universe. So, what is this local
What is the
universe?
meaning of local universe means? As I know, if you can mail me this question, just a minute, wait for a minute. I'll give you. Just wait for this. Nothing is local in universe. Everything is. Sorry, I'm not getting the slide. You can mail me, ma'am. Please provide him my phone number and my mail ID. I will answer this question as early as possible.
Okay, ma'am.
Okay.
And
Rajni, ma'am, please provide
Yes,
any
madam.
significance for scale factor, Hubble parameter, and distillation parameter?
scale factor and by
Scale factor, Hubble
taking a
parameter.
scale factor 80. There are so many types of scale
No, no,
factor. आप लोगों
any
को
significance for this? Any
बहुत
significance?
Yeah, it is very effective on the cosmological models. जैसे आपने स्केल फैक्टर बहुत से स्केल फैक्टर पर आपको काम हुआ है एक्सपोनेंशियल और हाइपरबोलिक स्केल फैक्टर एंड उससे आप बताते हो कि कॉस्मोलॉजिकल पैरामीटर कितना सस्टेन कर रहा है कितना ये कर रहा है
Okay.
Okay, Rajni,
जी ma'am.
please provide
Okay.
him my mail ID.
Hello, ma'am. I'm having one question. Can I ask? First question I'm having.
Yeah, yeah.
Ma'am, in slide number 2, can you show the distribution of matter of the universe?
Yeah. I just a minute.
Yes. Yeah.
I will also provide him the slides. I will share with you.
Okay, ma'am.
If you will have any problem about slide, any yeah, you can ask.
Okay, ma'am. 70% dark energy, 25% dark matter, and 5% ordinary matter. And that distribution you have shared heavy elements, neutrons, stars. Okay.
70% of the universe is
Actually, I wasn't knowing about this distribution: heavy elements, neutrons, stars, and free hydrogen and
3%
helium.
or 5% of baryonic elements, as you
Yes,
know
yes.
that. Baryonic,
Yeah.
read the advanced cosmology. जो baryonic का आप बात करते हैं, थोड़ा
Hmm.
cosmology literature पढ़िए, then you can find these heavy elements, neutrons and stars. These you can find in advanced research.
Okay, and ma'am, another question is, the universe is 13.5 billion years old, right? Approximately.
Yeah.
But
The
the
universe.
intergalactic distance is more than that, we can say, in giga years if we count.
Okay,
So, does it mean that the particles moved with the speed greater than light?
yeah, I'm not getting your question. Please ask again.
Uh, I asked, the universe is 13.5 billion years old,
Yeah.
approximately.
Hmm.
And intergalactic distance is greater than that if you count in giga years,
Actually, they are
light years, sorry.
yeah.
So does it mean that the particles moved away from each other with the speed greater than light?
They are mathematicians. These are the observatory results. Let's say age of universe is totally the research based on the physics. And as firstly, I told you that we are solving the theoretical problem of universe. तो हम लोग काम कर रहे हैं यूनिवर्स पर वो मैथमेटिशियंस जो है वो थियोरेटिकल प्रॉब्लम की स्टडी कर रहे हैं वो आपकी प्रॉब्लम आपका क्वेश्चन जो है कि मैंने बताया है कि द एज ऑफ द यूनिवर्स इज दिस जस्ट अ मिनट या
Okay, madam. I will share PPT mobile number and email ID on WhatsApp group. You can
या
contact to madam and
you
ask
can
any
share
queries.
and if these people have problem they can mail me and I will reply as early as possible. Okay. Okay.
Okay.
Okay.
Thank you, Rajni, and thank you, Madhuri ma'am, and very nice audience. They listen me very carefully, and thanks for inviting me. Okay.
Thank you, respected Dr. Shrika Srivastav Madam, for enlightening us on the topic general relativity and mathematical cosmology. I want to mention one thing here. Despite of her health issue, she taking efforts to present her topic very nicely. Today, in her plenary talk, she explained the cosmological principle, Big Bang theory, thermal history, and the big picture of expanding universe and its present scenario. She also briefly explained the general relativity, that is the theory of relativity, which is based on the Riemannian geometry. Madam also threw the uh, light on Einstein equation, cosmological model, and different kinds of dark energy model and modified gravity model. She deciphered the necessity of Big Bang theory and Hubble's law and many more things. Madam, your valuable talk on the topic will definitely upgrade our scientific knowledge. In order to become more competitive, we need to embrace the emerging technologies with respect to mathematical cosmology. Definitely, your guidance will help us in skill-based era with new education policy in India for the student participants. Okay, thank you very much, ma'am. Uh, Now we move towards for the second plenary talk. I would like to request Dr. Rajdi Putane, the head, the Department of Chemistry, to please introduce our eminent resource person for the next technical session. Over to you, Dr. Rajdi Putane, sir.
Thank you, madam. Good morning, everyone. I warm welcome to one and all on the behalf of Department of Mathematics and Physics, Sant Gadge Maharaj Mahavidyalaya Hingana, in virtual platform National Webinar on Development in Cosmology and Modified Gravity 2022. Myself, Dr. Rajdi Putane, Assistant Professor and Head at Department of Chemistry, Sant Gadge Maharaj Mahavidyalaya Hingana. It's my honor and pleasure to introduce second eminent resource person of today's webinar, her talk on review of recent work on modified theories of gravity and their cosmological consequences. Dr. Kalpana Pawar, Associate Professor and Head at Sri R.R. Lohoti. Lakshman, kindly,
Yes,
Lakshman
sir.
over there. Kindly mute Lakshman. Thank you. Dr. Kalpana Pawar, Associate Professor and Head at Sri R.R. Lohoti Science College, Morshi, affiliated to Sant Gadge Baba Amravati University, Amravati. She has huge academic and administrative profile in their profession. In academic qualification, she has completed SSC in 1990 from Sant Ursula Girls High School, Civil Line, Nagpur. She has completed HSC in 1992 and BSc in 1995 from SFS College, Seminary Hills, Nagpur, affiliated to RTM Nagpur City, Nagpur. She has completed their MSc in Mathematics in 1997 and PhD in 2002 from Government Institute of Science, Nagpur, affiliated to Rashtrasanta Tukadoji Maharaj Nagpur University, Nagpur. She has 22 years teaching experience, in which PG experience in 9 years and 16 years of UG teaching experience. She has taught as a lecturer at Government Institute of Science Nagpur from 1997 to 2006. She is assistant professor at Sri Shivaji College Art, Commerce and Science, Akola from 2006 to 2007. She had assistant professor at Shivaji Science College, Congress Nagar, Nagpur from 2007 to 2013, and she has associate professor at Sri R.R. Lahoti Science College, Morshi District, Amravati from 2013 to till date. She has 19 years research contribution in the place in the area of research, general relativity, cosmology, alternative theories of gravitation, and modified theories of gravitation. She has PhD supervisor at RTM, Rashtrasanta Tukadoji Maharaj Nagpur University, Nagpur, as well as Santa Gadge Baba Amravati University, Amravati of Maharashtra. She has produced two PhD two PhD student awarded in her guidance from RTM Nagpur University, Nagpur, along with four research scholars working on her guidance. She has published 20 research papers in national and international reputed journals. She has authored two books. She has organized several workshop, seminar, webinar on the topic of mathematical science, and many more topic over there. Many awards in her credit. She has felicitated as a certificate of excellence by University Women's Association Nagpur for obtaining PhD in 2003 in mathematics. She felicitated at Akhil Bharatiya Mahila Adhivesan by Antarang Mahila Chetna Manch, Vidarbha Hindi Sahitya Sammelan, Nagpur. She has awarded Shirdi Shri Sai Baba Gaurav Sanman Puraskar 2012 on 6th of April 2012 at Shirdi. She has awarded by Sai Maharashtra Samaj Bhushan Puraskar 2022 on 8th of April 2012 at Pune. She has awarded by Dr. Homi Baba National Award. It's a prestigious award in 2022 on 14 April 2022 by Mahatma Phule Talent Research Academy, Nagpur. She has awarded by Best Teacher Award by Shri R.R. Lahoti Science College, Morshi for the year 2016 to 17. She has worked in many academic and administrative committees. Now I request to guide and aware about the development in cosmology and modified gravity, Dr. Kalpana Pawar Madam. Over to Dr. Kalpana Pawar Madam.
Good morning. Good morning. Good morning to all the researchers, all the students of MSc Mathematics, Physics, all the faculty members, and organizers for giving me an opportunity to present my research work. Actually, I am not presenting my research work. I am just giving the review of the research work till date in the field of relativity, cosmology, and modified gravity. So here I am just giving the review. So if you have any queries, we can have the answer of the queries after the session. And I request all the participants kindly mute your mics so that you can listen me carefully, as I am not using the presentation. So wherever there is a need of presentation, I can give the presentation also. So as we know that the general theory of relativity is an outstanding accomplishment together with the quantum field of theory, and it is now widely considered to be the one of the two pillars of modern physics. The theory itself is couched in the language to differential geometry and was a pioneer for the use of modern mathematics in physical theories, leading the way for the gauge theories and string theories that have followed. It is no exaggeration to say that general relativity set a new tone for what a physical theory can be and has truly revolutionized our understanding of the universe. Now, as Shikha ma'am explained about the universe, so I'm not going into the details of it, only how this general relativity has been reached to modified theory of gravity. We will just go through it. So one of the most striking facts about the general relativity is that after almost an entire century, it remains completely unchanged. The field equations that Einstein communicated for the year 1915 are still our best description of how space-time behaves on macroscopic scales, in which we are using the Einstein tensors, energy momentum tensors, Newtonian constant, and the speed of the light. It is these equations that are thought to govern the equations of the universe, the behavior of the black holes, the propagation of gravitational waves, and the formation of the structures in the universe from planets and stars all the way up to the clusters and superclusters of galaxies that we are discovering today. It is only in the microscopic world of particles and high energies that general relativity is thought to be inadequate. On all other scales, it remains the gold standard. The great success of general relativity, however, has not stopped alternatives being proposed. Even during the very early days after Einstein's publications of his theory, there were proposals being made on how to extend it. And incorporated it in a larger, more unified theory. Notable examples of this are the Eddington's theory of uh, connections, then wide scale independent theory, and the higher dimensional theories of Kaluza-Klein. To some extent, these early papers were known to have been influential on the Einstein himself. They certainly influenced the physicists who came after him. The idea developed by Eddington, the Eddington in the year or in his theory during the period where later picked up by the Dirac, who pointed out the apparent coincidence between the magnitude of Newton's constant and the ratio of the mass and scale of the universe. This relationship between the fundamental constant and the dynamical state of the particular solution lecture that Newton's constant may in fact be varying with time. The possibility of in 1960s by Brans and Decay, who developed the proto theories of gravity. These theories are still the subject of research today. Richer set of structures that one could consider, and palanthra and proposal of were made by how to modify the effective field equations in 4 dimensions. By the early 1970s, and following the golden age of the general relativity that took place in 1960s, there was a wide array of candidate theories of gravity in existence that could rival Einstein's. A formalism that needed to deal with this great abundance of possibilities, and this was provided in the form of the parametrized post-Newtonian formation by Kenneth Nordtvedt, Tip Thorne, and Clifford Will. The Pippian formalism was built on the earlier work of Eddington and Decay, and allowed for the numerous theories available at the time to be compared to cutting-edge astrophysical observations such as lunar laser ranging, radio echo, and in 1974 the Hertz-Taylor binary pulsar. The Pippian formalism provided a clear structure within which one could compare and access various theories, and has been the benchmark how theories of gravity should be evaluated ever since. We will here the limits of general relativity have again come into the focus with the emergence of the dark universe scenario. So madam had already explained you that dark matter is having 70%. So due to which for almost 30 years there has existed evidences that if the gravity is governed by Einstein's field equation, there should be a substantial amount of dark matter in galaxies and clusters. More recently, dark matter or dark energy has also been found to be required in order to explain the apparent accelerating expansion of the universe. Indeed, if general relativity is correct, it now seems that around 96% of the universe should be in the form of the energy densities that do not interact electromagnetically. Such possibility that general relativity may not, in fact, be the correct theory of gravity to describe the universe of the largest scale. So the dark universe may be just another signal that we need to go beyond the Einstein's theory. The idea of modifying gravity on cosmological scales has really takes off over the past decades. This has been triggered in part by theoretical developments involving higher dimensional theories as well as new developments in constructing the renormalizable theories of gravity. More phenomenologically, Bekenstein's relativistic formulation of Milgrom's modified Newtonian dynamics, that is MOND, has provided a fresh impetus for new study. What was previously a rule of thumb for the how big gravitational fields might behave in regions of low acceleration was suddenly elevated to a theory that could be used to study cosmology. Inside such Bernstein's realization that large-scale perturbations in the universe can be directly related to the overall expansion rate have also made it possible to characterize large classes of theories simply in terms of the how they make the universe evolve. Finally, and just as importantly, there has been tremendous progress observationally. A key step here has been the measurement of the growth of structure at redshifts by Guzzo and his collaborators. With these measurements, one can test and reject the large number of proposals for modified gravity. This work is complemented by many others that carefully considered the impact of modifications to gravity on this cosmic microwave background, that is CMB, weak lensing, and variety of other cosmological probes. As a result, testing gravity has become one of the core tasks of many current and future cosmological missions and surveys. Now here we have many developments that have occurred in the field of modified gravity over the past few decades. We still focus on how these theories differ from general relativity and how they can be distinguished from it, as well as from each other. A vast range of modification theories not exist in the literature. Some of these have extra scalar, vector, or tensor fields in their gravitational sectors. Some take Sakharov's idea in an altogether new direction, modifying gravity in regions of low rather than high curvature. Other expands on the ideas first put forward by Kaluza and Klein and take them into new realm by invoking new structures. Indeed, as the reader will see from the content, that there are now great many possible ways of modifying gravity that can in principle be tested against the real universe. So here we have aimed to make this self-contained section that focuses on some extent on why general relativity should be considered special among the larger class of possibilities that we might consider. So let us now spell out the conventional and definition that we will throughout this review. So the definition which you are using the line element for the Minkowski space, which is known to you, that is d square is minus dt square plus dx square plus dy square plus dz square. For the Riemann and Einstein's curvature tensor, we will adopt the convention of Misner, Thorne and Wheeler, that is curvature tensor. Then we are having the Einstein things are which are having the general form which are known to you from the general theory of relativity.
हो हो
So,
एवढंच मॅडम एक्सप्लेन जनरल रिलेटिव्हिटी
so you
डार्क
are
मॅटर
aware
डार्क
of all
मॅटर
these things. Now we know that
हो
let us now
मॅडम
move
एक्सप्लेन
on to the
जनरल रिलेटिव्हिटी
definition of
डार्क एनर्जी
particular
डार्क मॅटर
terms. We choose the
अँड
we
टॉपिक
define
काय
the
तुमचं
equivalence
लेक्चरचं
principle
लेक्चरचं
in three different
हां
ways. Okay, so there is
डार्क
weak
मॅटर
principle or weak equivalence principle. It means that all uncharged, freely flowing test
फक्त
particles
एवढंच
follow
मॅडम
the same trajectories once an initial position and velocity
हे
have been
फक्त असं
prescribed.
लिहिणं मॅडम एक्सप्लेन जनरल
Then
रिलेटिव्हिटी डार्क
Einstein's
एनर्जी डार्क
equivalence
मॅटर इन
principle states
सिम्पल
that
लँग्वेज
the
वगैरे सगळं त्याचं घेऊन टाका
weak equivalence
हो
principle is valid,
दोन्ही
and
सुद्धा
furthermore,
बोलतो
in
मी
all
सगळ्यांना कॉल करून
freely
घेते
falling frames, one recovers
आणि एखादं वाक्य असेल तर
locally
मग पुन्हा
and
पाठवते
up
सगळ्यांना
to
कॉल
the
केल्यानंतर
tidal gravitational forces, the same laws of special relativistic physics, independent of position on and the velocity. Then strong equivalence principle, it states that the weak equivalence principle is valid for massive gravitational objects as well as test particles, and in all freely falling frames one recovers
हॅलो
locally and up to the tidal gravitational
हॅलो
forces the same special
जनरल
relativistic
रिलेटिव्हिटी
physics independent of
हो
position or
डार्क एनर्जी
velocity.
डार्क
So
मॅटर
based on
इक्विव्हॅलन्स
these
प्रिन्सिपल
equivalence principle, the main we are using is the
इक्विव्हॅलन्स प्रिन्सिपल पण वाचून
Einstein's
घ्यायचं
equivalence principle, to which we are following the general theory of relativity. So
ठीक आहे मी कॉल
the
सगळ्यांना कट करते
Einstein equivalence principle in particular is known to have been very influential in the conception of general relativity. One may note the some authors refers to what we had called the Einstein's equivalence principle as the strong equivalence principle also. So let us we define what we mean by general relativity, because mathematical expression is important for us. So being a mathematician, the researchers, whatever research is going in the general theory of relativity, cosmology, and modified theories of gravitation or alternative theories of gravity. So we are using the term general relativity. This term we are generally using for the Einstein's equations of motion. So when we use Einstein's field equations, then we are calling the problem is of general relativity problem. So particle physicists, on the other hand, refer to any dynamical theory of spin to fields that incorporates general covariance as general relativity. Okay? Even if it has field equations that are different from Einstein. Now in this, we are using general relativity as only the Einstein's field equations, because in mathematics we are using Einstein's field equations for the general theory of relativity. So when we discuss modified gravity, this will refer to any modifications of these field equations. However, it will be clear from reading that we are having the general relativity based on the Einstein's field equations. Okay. So hereafter we are using these terminologies for the Einstein's field equations as the general relativity. Now general relativity is the standard theory of gravity. Here will some its essential features are its foundation, that is in 1919 Einstein had developed special relativity into the general theory of relativity on the basis of the principle of equivalence and principle of covariance. Okay, so here uh, why we how we can say that general relativity exists or it is valid. So requirements for validity of this is that in order to construct the relativistic theory of gravity, it is of primary importance to establish the properties it must satisfy in order for it to be considered viable. These includes fundamental requirements such as the universality of free fall and the isotropy of the space, as well as compatibility with a variety of different observations involving the propagation of light and the orbit of massive bodies. Today, radio and laser signals can be sent back and forth from the Earth to spacecraft, planets, and the Moon, and the detailed observations of the orbit of a variety of different astrophysical bodies allow us to look for ever smaller deviations from Newtonian gravity, as well as entirely new gravitational effects. It is in this section that we will discuss the gravitational experiments and observations that have so far been performed in these environments. So the foundation of relativistic theories, in which we are having the theories. So Lagrangian density, we are knowing the definition. Observational test of metric theories of gravity that has been there. So this is in physics, which we are not going to go into the details of this because these are not our area of interest. Okay. So our basic area of interest is that, so how these theories have been developed and what are the facts which we are using, the terminologies which has been used while doing the research. Okay. So while doing the research, we are having the terminologies like ghost. Sometimes the word ghost is used. Ghosts are the common features of many modified gravity models that hope to explain dark energy. Intuitively, it is easy to see why this might be the case. To create cosmic acceleration, we need an additional repulsive force to act between the massive objects to large distances. If this force is to be mediated by the particle of even spin, such as a scalar of spin 0 or tensor of spin 2, then the kinetic term describing this must have the wrong signal, that is, it must be a ghost. We should be clear about the distinction between the kind of ghost that arises in certain modified gravity models and we are using this quantization of non-abelian gauge theories. The latter is introduced in the path integral of to absorb the unphysical gauge degrees of freedom. It does not describe the physical particle and can only appear as an internal line uh, in the diagrams. It contrasts the ghosts that haunt modified gravity, described physical excitations and can appear as external lines in diagrams. So here we are using some terminologies like strong coupling. Then some modified gravity models are said to suffer from strong coupling problems. So researchers has to take care of it. The strong coupling scale is of course dependent on the background of the classical solutions and may even depend on the position in space-time. Whether the inferred strong coupling scale is acceptable or not again depends on the background. So such type of terminologies will occur. Now we are using here, we have to modify the Einstein's theory. We have already studied maximum times we are using Einstein's theory in terms of the Riemannian geometry. Now if we use the same Einstein's theory in terms of the manifold theory, okay, so having considerable requirement that must be satisfied by the variable or viable relativistic theory of gravity, let us now consider Einstein's theory of general relativity. In particular, general relativity satisfies all the requirements described by the construction by trial and error method. General relativity in a gravitational theory that treats space-time as a four-dimensional manifold. Someone asked the question before this session that what is four dimension. Okay, so four dimension, I think this is the basic idea of four dimension. It is since from the Newtonian itself that space and time, these are not two different things. When we talk about the motion, so to take the motion of any rigid body, we require or to specify the position of this point or the particle or the system, we require the position is always with respect to time. So as time changes, position may change. So in motion, time plays an important role. So we are considering fourth coordinate with respect to three space coordinates, one more coordinate as a time coordinate, and we are using space time coordinate system as a four-dimensional coordinate system. Okay. So here in relativity, the four dimension means space-time coordinates. Okay. So the connection associated with the covariant differentiation should be viewed as an additional structure on the manifold theory. So manifold theory we are using specially in case of the modified theory, we are using Einstein's field equations are converted, and these converted equations will be in the form of the uh, action principle. We are using the action principle and we are modifying the theory. Okay. So I'm not giving the details mathematically. Why? Because it requires the explanation on board. Because I don't think that if merely I give you the equation and the screen and you can understand everything. I don't think so. Okay. Still, if you want, I can show the action, what is action, and I can share it just to show you. Okay. Okay. You can, is it visible to you?
Yes, madam, your screen is visible.
Okay, so the action is defined as the most field theories. The field equations can be derived from the variation of action. In case of general relativity, this is the Einstein-Hilbert action given by this formula number 34, which I have given you. Okay. So, in which what is this Lm? Lm is the Lagrangian density of matter field. Psi, the gravitational Lagrangian density, has been taken to be, which is Lg is under root of minus g r minus twice lambda upon 16 pi g. This assume the Ricci scalar to be the function of the metric only, so that we take r is function of g. So this is what, but this again has various forms with respect to what kind of equations you are going to solve. Okay? And there are many modifications in the modified theory of gravity. So I am not generalizing things. Okay? Because according to your requirement, you have to change the calculation part, and you will find that it becomes very complicated. You cannot by just observation cannot say that what kind of relations you will get. Okay? So this is what we are having, because this is the metric which is known to you. ds square is equal to, this is in Riemannian metric, it is given by g mu nu dx nu. This line element can be converted in the Minkowski description of the transformation called tetrad as follows, which is eta ij is equal to eta I minus theta I. Now theta squares diagonals are also given. So that is known to, nothing new I have given, but these are the formulas. Those who are working in the modified theory, they are knowing these formulas which are taken from the manifold theory. So now alternative theories, you all know that in alternative theories, scalar tensor theory, then you are having branch decay theory. I'm not going into the details of it because this is the part of research. Researcher has to work on it and give his calculation and conclusions. Okay? Then general scalar tensor theories, then modified Newtonian dynamics. Some of the theories that we will discuss is constructed to give the modification to Newtonian gravity on galactic scales. To be more specific, they should lead to Milgrom's modified Newtonian dynamics, also known as MOND, in regime of low acceleration. Okay. So this is MOND theory, which is known as modified Newtonian dynamics. I don't know, students are belonging to the research group or they are belonging to the MSc group, because based on that only I can say things. Otherwise, whatever I am giving, they find that it's very difficult. Madam is just telling some story like this. So this is what I can find. So in this review, what we have discussed recent advances in gravitational physics, many of which have been driven by the discovery of the dark side of the universe in the late 90s. In this final section, let us now briefly consider the outlook for future gravity research, and in particular, what we consider to be some of the upcoming highlights. From a theoretical perspective, model building is an important part of understanding and explaining existing data, as well as making predictions for the future. So some students have asked the question, what are the cosmological theories? models, how we can find it, how to construct the cosmological models. So to construct the cosmological models, so in which theory you are going to construct the cosmological model is very important. If you are using the alternating theory, then you have to choose. In alternating theory there are many theories, so you have to choose the theory and accordingly calculations are there and you can construct. So basic idea is that you have to solve the field equations, and by solving the field equations you will get certain second order differential equations, partial, or you can get the non-linear one, and you solve them, and their solutions will be the exact solution, or we can call that as the model of the universe. And then you have to predict it physically, and your observations must be in good agreement with the results which are already contributed by the physicist. So you have to be in good agreement with your values, or whatever you are writing, that should be in good collaboration with the physicist predictions. So that will complete your paper. So those who want to describe a model of universe or any cosmological models, just to work out, you have to consider some metric, then using that metric, for that metric you have to solve the Einstein's field equations. Again Einstein's field equations in using the theory. If you want solving in Brans decay, so you have to consider the field equations of Brans decay. If you are considering in Lyra's geometry, then you have to consider the field equations of Lyra's geometry. So you have to consider according to the required theories. So if you are doing in modified theory of gravitation, so in that case you have to stuck on that. Okay? So orally we cannot say the how to construct the model or how to get the cosmological model. You have to work out on it. Being mathematicians, you have to do many calculations, and then you have to come to the end with the solution. And if you solve all the problems, that is differential equations, then you can get the final answer in the form of the exact solutions, and that will give you the cosmological models. Okay? So here we have, from the theoretical perspective, model building is an important part of understanding and explaining the existing data as well as making predictions for the future. Tight constraints always already available on solar system and astrophysical scales. However, mean that model builder are presented with a choice. They can either study minimal deviations away from the general relativity, or must otherwise look for the mechanisms that hide modifications to gravity on the scales probed by the experiment. The former of these has value for the understanding the spatial nature of the general relativity and the consequences of uh, moving away from it, while the latter provides an exciting opportunity to try and solve some of the cosmological puzzles that have arisen with the discovery of dark matter and energy. Modified gravity necessarily involves additional fields, extra dimensions, or broken symmetries, since we know that general relativity is the unique deformism invariant theory of the single rank to tensor that can be constructed from the metric variation of an action in 4 dimensions. An important consideration is then whether or not these deviations manifest themselves at the level of the background cosmology or merely at the level of the perturbations. Of course, if we wish to account for the dark energy and solve the cosmological constant problems using modified gravity, these deviations must manifest in the solutions of the traditional problems. We must also require here that there are many applications of standard cosmology, such as the evidence of light elements, the peak portions of the CMB acoustic spectrum, or the predictions for baryons acoustic oscillations. This requires the background FLRW cosmology, that is prediction cosmology for the modified theories closely mimic the standard evolution of lambda cdium from nucleosynthesis through to a matter domination. So let us now consider consider the assumptions to go into the standard cosmology. This includes Einstein's field equations, the universality of the free fall, local Lorentz invariance, three spatial dimensions below the electroweak scale at least, then conservation of energy momentum, then homogeneity and isotropy of space and large scales, then matter fields being well modeled by fluids of dust and radiation. So these assumptions, when confronted with the observations, required the presence of dark matter and dark energy. From a particle physics perspective, this is very discomforting as we have discussed, as it is required the vacuum energy to be at least 60 orders of magnitude smaller than the expected from particle theory. This problem is exaggerated by the fact that contributions from the 0 point energy of massive particles changes as the universe grows and goes through this transition. Okay, so we know that at the early stage of the universe, that is before 14, 13.4 billion years ago, the universe was started expansion, but nowadays this expansion earlier at the earlier stage it is a deaccelerating universe was established, but nowadays in last 2 decades you find that the universe is expanding and accelerating. Okay? So to circumvent the difficulties that this entails, many model builders therefore assume some unknown symmetry that sets vacuum energy plus a contribution from their cosmological constant to zero. To account for cosmic acceleration, they then require modifications to gravity on large scale. So these are some points we have to keep in research. It is also crucial to ensure that the models obey some basic requirements of stability. There is little motivation for carrying out complicated simulations and devising expensive experiments to probe theories that are fundamentally sick. For example, we may choose to ask if the theory contains ghosts, which can lead to the catastrophic instabilities unless the mass of the ghost lies above the effective theory cutoff, as described in the previous section. Ghosts are rife in modified theories of gravity, and dealing with them is of the principle of challenging faced by modern builders. Another important key to establish is the cutoff for our effective classical theory. Modified theories of gravity can be strongly coupled at lower than expected energies and enter the quantum fog. If we want an effective theory description of gravitational field at the surface of the Earth to be classical, we need to impose that the cutoff is at least of the order of few MeV. Since we wish to impose that the classical descriptions of gravitational fields around the Sun should be trustworthy, at least down to its Schwarzschild radius. So, so while doing research, we have to consider many things, and mere calculation will not give you the result. So nowadays you will find that if you observe the research papers on the gravity, that is in the modified theory of gravitation, so you will find that there are papers on f of r gravity, then f of g gravity, f of rt gravity, f of q gravity. Now these are taking place, and you will see that in those research papers they have taken the graphical representation also. So why this graphical representation is used? Because without the graphical representation you will not find when you are having some problem because that ghost may occur, and you have to remove that thing. Only theory can accept it, because we are just given the theoretical predictions. So we mathematicians, we try to give only the theoretical predictions. Now these theoretical predictions, so in these theoretical predictions we can see that sometimes the things which you are getting and the things which are happening are not matching, so you have to match both the things. So This is all about the research in modified gravity. If you have any queries, you can ask me. Is there any question from the audience?
Good morning, ma'am.
Good morning.
Ma'am,
Yes, sir.
detail about the numerical study of cosmological model.
Yes, you can get it from the researcher. You can
Yes,
get
ma'am.
it from me also. So when you will be in the field of research, your guide will explain you how to follow the steps for the research, because you cannot get a numerical study directly, because you have to consider the problem for that case.
Okay.
So I have given the general idea that you have to consider the metric, then you have to consider the field equations, in which theory you are going to do the research, and based on then you have to solve those field equations for the given metric, and the whatever the differential equations you will get, you have to simplify them. You have to get the solutions. You have to find out the unknowns and rewrite the unknowns in terms of your uh, original line element, and the whatever you will get, that is known as the exact solution. Then you have to predict. Again, there are some terms which are physically and kinematically very important. You have to evaluate those terms and you have to predict them physically.
Okay. Uh, Hello, ma'am. I'm having a question.
Yes, Nikhil.
Ma'am, modified gravities and dark energy, we used to explain the accelerated expansion of the universe, right?
Yes.
So, can we combine both modified gravities as well as dark energy? And what is the difference between dark energy and the modified gravity?
In the modified gravity, we are considering dark energies. Modified
Okay,
gravity
so
itself
the
considers
forms
the
we dark
dark.
energy. Then what are the forms we have for dark energy? That is quintessence, Kaysen's, cosmological constant, or Chapelian gas. So what the
There
role they
are
are playing?
various forms. There are various
Yes.
forms. Yeah,
What
there
are
are
the role they are
various.
playing then? Uh,
There
what are
are
the role?
various forms.
Yes, from these quantities, whatever we have discussed now, the Chapelian gas or cosmological constant.
Yeah, based on these
Uh,
various forms, you will get
uh,
different cosmological models, and you have to compare this with the standard one.
different cosmology. No, ma'am, I'm asking actually what is the difference between by taking these quantities as a candidate of dark energy and the considering the modified gravity. The another question is, can we combine them? Means, in modified gravity, can we take the form of a dark energy? Anything, let's say,
Yes,
the
we
Chapelian
can.
gas.
We have to. Yes, we can consider various forms of the fluid, various form of the gases, because we know that this matter distributed is of different form. So you have to consider, and based on that, you are getting the different result.
Actually, ma'am,
But
my
whatever
question is,
result you will be
uh,
getting, that you have to compare with the existing one, observational things, and the results you are obtaining must be in good agreement.
okay, then what is the difference between this modified gravities and the these quantities or the candidates of dark energy?
I didn't get your question.
Okay,
Uh,
thank
o-
you.
okay, madam, we have some question from participant. The question from Atish Go, that is, what is the base for GRT gravity?
F of RT or G of F of, what is the question? Let's see. Yes. What is the base for G of RT gravity? I have not studied up till now on G of RT gravity, so I can't answer about this. I have to study on this, then only I can answer it.
Okay, madam. Now, next
Yes,
question is.
Atish.
Hmm. Next question is, in f of q2 gravity,
Thank you,
can we
Atish,
ma'am.
we
use
can
BNT
discuss
types?
it later on.
What, madam?
Yes, yes.
Okay.
F of QT gravity can we use Bianchi type 1 and 9? 1 and 9, as lot of work has been done by using FLRW line element only. Uh, you have once we have to try it, then only we can see, because I cannot say that just by observation the result. Only by after calculation we can predict that whether it is existing or not. You have to try it. Talk to the gravity for the BI type 1 and Bianchi type 9. You have to try it. There is Sheetal. Sheetal, are you listening to?
Yes, ma'am. Yes, ma'am.
Yeah. So whatever line element or whatever function you consider, you have that is not error based. You cannot research papers just by observation. You cannot decide that this will happen or not. So you have to make calculations, do the calculations, and then you have to decide whether that theory is applicable to so and so type metric or not. Okay.
Okay, ma'am. Okay, ma'am. Yeah. Thank you, ma'am.
Humble request to all
Ma'am,
participants to share question in chat window because of time constraint. I will share your question with madam and madam mobile number and also email ID.
can I
Yeah,
ask a question,
that
ma'am?
will be
Or
fine. Yes,
Okay.
yes, Nikhil.
I'm asking, I want to ask is the recent observation shows that the universe is homogeneous and isotropic, right?
Yeah.
So is there a point of considering the anisotropic line elements?
Uh, yeah.
Because
Still, you
Bianchi
have
1 to 9, these are anisotropic, right? And the
yeah,
recent
yeah.
observation
Because
shows this is isotropic. So,
why we are doing in anisotropic, then the reason is that as you know that in the early stage of the expansion it was deaccelerating. Okay, now it has changed to acceleration. So this is the changes. So there may be some changes in future also. So you have to see the results whatever you will be obtaining for the anisotropic, whether they are in agreement with the given one. Okay, so you can create a new theory in future. So you have to keep doing the things. So you have to consider all the cases whether they exist or not. That is the question later on. But first you have to try what you will get after considering those things. Okay, is there any other question?
thank you.
Yes, one more question from the participants?
Okay, so I would like to thank the organizers for giving me an opportunity to present the recent research work on the modified theory of gravity. Thank you one and all, and also thanks to the audience for asking the question, because it seems that there are many upcoming researchers in our country, and they are definitely will be working on the modified gravity. So thank you one and all. Thank you.
Okay. Uh,
Thank you very much, ma'am.
uh, Let me start. Dr. Rajni Madam?
Yes, madam.
Yes. Thanks a lot, madam, for your valuable information regarding the review of recent work on modified theories of gravity and their cosmological consequence. Madam elaborately explained the various Einstein theory, Newton's theory, and theories of gravity. She also simplified the concept of general relativity, dark energy, and dark matter in very simple and lucid language. Madam give the basic ideas about the cosmological models, Einstein field equation, modified gravity, and many more things which justify the topic. Madam, the information given by you in the context
नाही झाला आता मला लगेच हंड्रेड सेकंड मॅडमचा वाटतच नव्हता
Ma'am, your mic is off.
Yes, ma'am, we can't hear you. Yes, now it is audible.
Okay, sir. Thanks a lot, madam, for your valuable information regarding the review on recent work on modified theories of gravity and their cosmological consequences. Uh, Madam give the information about the various Einstein theory, Newton's theory, and theories of gravity. She also simplified the concept of general relativity, dark energy, and dark matter in very simple and lucid language. Madam give the basic ideas about the cosmological models, Einstein field equations, modified gravity, and many more things which justify adoption. Madam, your information given by you in the context of topic will ignite the student and budding researchers to explore their ideas for further scientific research. So thank once again and good time ahead. Now, now, it's time for concluding remark. I request Dr. Ritesh Kohre sir, the head Department of Physics, in charge of Science Faculty and convener of the today's webinar. It's our sincere appreciation to sir for taking efforts for advanced planning of the program which made this webinar such a grand success. So please, Dr. Ritesh Kohre sir, over to you.
Thank you so much, madam. Am I audible?
Yes, sir.
Okay. Thank you, madam, for giving me this opportunity to propose a formal concluding remark of this webinar. So, entitled National Webinar on Developments in Cosmology and Modified Gravity 2022, which is one of the recent and hot issue for all the researchers and all the research scientists for their upcoming studies. So, as one of the convener of this webinar, I first welcome all the resource persons and participants for gathered on the scientific platform for this webinar. We could arrange this webinar. We could not arrange this webinar without the consistent encouragement of our Honorable Secretary Shri Udayji Moglewar of Basveshwar Education Society, Honorable Dr. Aarti Moglewar Madam, Principal of this institution, and Honorable Dr. Ganesh Maivade sir, the IQAC coordinator and one of the coordinator of this webinar. So let me introduce shortly about our institution. It is situated in the Hingana, which is the Tahsil place in the Nagpur district and Maharashtra state. So this institute has been started in 1990 and it is managed by Basveshwar Education Society Nagpur, and it was founded by our source of inspiration Dr. Sudhakar Moglewar, with an objective to provide the access to the quality education from the students from the rural areas, and it is situated at the banks of Vena River at Hingana, in which students can study the art, commerce and science faculties in different streams. So once again, we welcome all the participants gathered from different states of India for this webinar, which has a number around 200. And definitely, when we were going through this webinar, we observed the resource person present thoroughly the comprehensive study on the recent works on modified theories of gravity and their cosmological consequence. And definitely, when we planned this webinar, it was planned in a very short span of time, and definitely the conveners, one of the convener, Dr. Rajini Shelote madam, and the entire team of our science faculty, the heads of various departments from art, commerce and science, has taken the untiring efforts to make this event a successful one. And the purpose of this national webinar was definitely to provide a reference tool for the upcoming researchers and the scientists in the field of cosmology and modified gravity, as well as the subjects that have been taken for discussion in this webinar were discussed in the past decades, and they were largely motivated by the rapid progresses in this field. So, the precision test of the fundamental physics on the scale of observable universe. I'm happy and fortunate that our resource persons, Dr. Shikha Srivastava madam and Dr. Kalpana Pawar madam, entirely covered all the necessary topics related to this field, starting from the cosmological models of universe, the time dilation, the length contraction, and the expansion of universe, the observed cosmic accelerations, the Riemannian geometries, and then they move towards the Einstein field theories, the dark energy, the dark matter. So it's infinite thing. The research will not stop here. It will continue forever. Red shifts and blue shift they explain very excellently, and then they move towards the particle physics and hope. I'm sure you have enjoyed this all the topics related to the developments in the cosmology and modified gravity. With this, I extend my heartiest thanks to the resource persons, our patron, our principal ma'am, our coordinator, Dr. Ganesh Maivade sir, and the entire team who is continuously taking the efforts to make this event a successful one, because I was not there in the process since last four days, but still, all in all, it is a successful organization. So, hope you will enjoy the rest of the perspective of this webinar. Thank you so much.
Thank you so much, sir. Despite you are on the medical leave, still finding the time to attend the webinar and express the concluding remark of the webinar. I appreciate and grateful for your support, and thank you once again.
Thank you so much, madam.
Now I request Dr. Ritesh Zumre sir, the Department of Physics, to propose the formal vote of thanks.
Okay, thank you, ma'am. Good morning, everyone. I am honored and lucky to have the opportunity to propose a vote of thanks on this occasion of National Webinar on the Advance in Cosmology and the Modified Theories of Gravity, 13 April 2022. I express my sincere thanks to distinguished resource person for the Dr. Shikha Srivastava Madam, Professor, Department of Mathematics, Aligarh Muslim University, and the Dr. Pawar Madam, Head and Associate Professor, the Department of Mathematics, Sri R.R. Lahoti College, Morshi, for their wonderful speech where she mentioned the brief study of the cosmology and the modified theories of the gravity. The way in which both they explained the subject was an extraordinary to helpful for the research students. I would like to explain and I would like to thank the respected Sri Uday G. Moglewar sir, the Secretary of Bashweshwar Education Society, Nagpur. Also, I would like to extend my thanks especially to the Dr. Arti Moglewar Madam, Principal Sant Gadge Maharaj Mahavidyalaya, Hingana, District, Nagpur, and also to the thanks the Vice Principal and IQAC Coordinator, Dr. Ganesh Maivade sir. Also, I would like to express my thanks to the convener, Dr. Rajni Anturkar Madam, Head Department of Mathematics, Maharaj Mahavidyalaya. Also, Dr. Ritesh Kode sir, Head Department of Physics, SGMM College, Hingana. Also, the Dr. Vanjari Madam, the Head Department of Mathematics, Sindhu College, Nagpur. Also, add thanks to the Saroj Kumbhare Madam, Assistant Professor, Department of Mathematics, Amalakchand College, Mahavidyalaya, Yatma. I express my thanks to the Dr. Rupali Chaudhary Madam for such a nice presentation and hosting this webinar. Also, specially thanks to the organizing team, including the Dr. Rajdeep Putane sir, Dr. Madhuri Bonde Madam, Dr. Amit Karbande sir, Dr. Rupali Chaudhary Madam, Dr. Madhuri Thakre Madam, Professor Prashit Walke sir, Professor Ankit Madankar sir. Also, respected the professors and the staff members and their students. I also specially thank to the Sri Ajay Anturkar sir for the technical session. Finally, I I also express my gratitude for those who directly and indirectly took part to make this a grand success. Thank you so much, ma'am.
Okay, thank you, sir. Let me conclude. Dr. Rajni Chelote, madam.
Yes, madam.
हाँ. With the prior permission of convener and all the organizing committee, here I am declare that this program is over. Thank you.
Okay. Unofficially, I would like to mention something here. Dear participants, your certificates will be uploaded on the WhatsApp group what we created within 5 to 6 days. The PDF copy of the entire certificates will be provided. So kindly fill up the feedback form precisely and clearly what you required on the certificates. Kindly do not mention the doctor in the designation and doctor in front of your name, because it will reflect as doctor and your name. So only mention your designation in the that field, and plainly write your name. That will reflect on your certificate. So your certificates will be ready within 5 to 6 days, and we will upload the PDF copy on the WhatsApp group what we created. Over to Charlotte, madam.
Okay, sir. And also we will provide on your register.
Audible. You are not audible. Charlotte, madam. You are not audible. No.
Okay. Also, we will provide your certificate on your registered email ID.
Right,
And
right.
now, with the permission of all dignitaries, now this program is over here.
Okay, okay, madam.
I request all the organizing committee to be